Hello everyone. In this video we will see the question that is count inversions in array or also known as counting inversions. So it is a question that is asked in Amazon, Google, etc. So it is a popular and most common question. So this question is basically we are given an array that is in this we are given an array 2 4 1 3 5. So we have to count the inversions. So what are the inversions? So inversions are the two elements of the arrays whose like for this example in this. So if we are given that this is our condition that we are given. So basically I is the smaller index than j. So if I is this like for I is this 4, so I is smaller than j is at here, if suppose, then if the value of array of I, so that means 4 is greater than array of j, that means this 1, so 4 is greater than 1, so that means this is an inversion. So basically inversion is if the array is not in sorted order for the particular elements. So in this array all the possible inversions will be we have to count the inversions. So we have to only output the inversions. We don't have to sort the array. So we have to only output the number of inversions. So in this array the inversions are 4, 1. So you can see 4, 1. So index of 4 is less than index of 1, but 4 is greater than 1. So this satisfies our condition. So this is an inversion. So again 4 and 3, they are also satisfying our condition, and 2 and 1 are also satisfying our condition. So these are all the three possible inversions which will occur in this array. So we have to output the number of inversions, so which is 3. So let's see how to approach this question. So if you are asked this question in an interview, so you will have to start with the brute force approach, which you can like think probably faster than the other approaches. An interviewer will also be happy if you give him this approach quickly. So for this you can simply think that these are our array elements. So you can see 2 4 1 3 5. As we saw, the answer is 3, as the number of inversions is 3. So I have written the indexes here. So in this you will traverse for every element again. So that means we will use two nested loops. So if we are one loop will traverse the whole array, and the other loop will traverse the array after that element which is being traversed by the first loop. So if our value is at here, you can see I is here, so then j will traverse let me again make this. So j will start traversing from I plus 1, that is from here, and it will check. We will maintain a count variable. You can see I have written the pseudocode. So we will maintain a count variable, and we will check for every element if we satisfy this condition. So at this you can see it does not satisfy any condition. This will satisfy the condition. You can see j will increment and j will come here. So you can see this condition is satisfied. As you saw, the 2 is greater than 1, but the index of 2 is less than 1. So like this we will iterate over all the elements, and we will check for the counting inversions. So we will check for the inversions, and we will increment our count if we see a particular condition, this condition getting satisfied. So this way the time complexity of the solution will be O of n square. As you see, we are approximately O of n square, as we are traversing the array every time for every element that we are on. So it will take only constant space, because we are not using any space. We are just maintaining a count variable, and we are incrementing it simply by satisfying the condition. So interviewer will ask you to optimize this approach. This is a good approach, but he will ask you to optimize it. So to optimize it, we will use a merge sort technique. So basically, if you don't know what is a merge sort technique, so it is a divide and conquer to sort the array, divide and conquer strategy to sort the array. So let's see how it works. So if we are given this array that is 2 4 1 3 5, so we have to sort it. So how will we sort it? So we will as it is a divide and conquer, so we will calculate the mid for this particular array. So mid will be like you can see I'm writing here, mid will be left is 0, that is 0 1 2 3 4. So these this array contains 5 elements, so 0 to 4. So 0 plus 4 divided by 2, so we will find the mid. So it will be 2. So it will be 2. So we will now split our array into this 0 that is left, 0 to 2, then 2 to the 4. So 2 occurs here, so you can see 0 1 2. So we will split our array, that it will become 2 4 1, and the other part will be 3 and 5. Then we will split this array, then we will split this array, then this, then we will come to this side of the tree. So you can see recursion tree will come here afterwards. So now we are at this point. So now we will again calculate the mid for this. So 0 plus this is 2, 0 plus 2 divided by 2, it will be 1. So 1 will be 0 and 1, so it will be split over here, 0 and 1, and this 2 will be separated. So now you can see again we are getting we will split the array till our left is less than right, at this point you can see our left is not left less than right, they are equal. So that's why for the single element left is not less than right, they are at equal index, so they won't be splitted, you can see. And the basic of this approach is that every single element is sorted in itself, so we don't need to sort 2 and 2 for itself. So now afterwards we have splitted this array. For similarly for here also we will split the array. Now we have to merge this at this point, so we will check if 2 is less than 4. So yes, it is 2, so we will maintain a result array, then we will add this 2 in there, so these are sorted, so it will say as it is 2 and 4. Then we will check for this, so now 1 comes here, so you can see 1 is less than 2, so it is in second array, so its index is greater than 2, but it is less than 2. So now we will just add the 1 before 2 in the result array, then we will add 2, then we will add 4. Similarly, this is how we merge the array. For example, in this you can see 3 is less than 5, so it will be simply added in the array, that is 3 and 5. Now if we come here, so our output is 1 2 4 and 3 5 at this point. So now we will this will be 1 2 and 4, this is 3 and 5. So now to merge them we will have one pointer here similarly as we saw on the earlier steps, so and one pointer here. We will check if 1 is smaller than 3, so yes, it is smaller, so we will simply add it to the resultant array. Now I will increment simply to this index, so then we will check if 2 is smaller than 3, so yes, it is also smaller than 3, so simply 2 will be added to the array. Now we will check our pointer will be at this point, that is 4, and it will be at 3, so now 3 is smaller, so now 3 will be added in the array. Now similarly our this pointer will increment, so the 3 has been added, so it will increment to 5. Now 4 is less than 5, so 4 will be added, and now afterwards 5 will be added. So this is how we merge the array. First of all, we split the array into single elements, then we go to upper steps and merge the array and sort them at each step. So this is how the merge sort works, and it takes time complexity of n log n. N is for traversing and log n is for this recursion call. So now let's see how we can use the merge sort technique to count the number of inversions. As you saw, we used the merge sort to break the array. So at every point when we break the array, we sort to merge the array, we use 2 pointers, that is one pointer points to this index and one points to this index. So we will maintain a count variable, so we will simply maintain a count variable. You can make it pass it by reference, or you can simply make it global, and but global is not used that much, so it is expected you to make the reference variable. So now if you see 2 is less than 4, so our count won't increment because 2 is less than 4, so you can simply copy the 2 and 4 in the array. So now you can see we have got the 2 and 4. So now if you see we come here, 2 and 4 are sorted. So now now if you check, 1 I will be here, here first pointer will be here and second pointer will be here. So now if you check, 1 is smaller than 2, so that means if 1 is smaller than 2, the first element only in this, so it will be smaller than other elements also, because 2, this array is sorted, we have got the sorted array. So basically that means all the elements occurring after 2 will be sorted, so they will be increasing, so 1 will be smaller than all. So we have to simply this will be we will see how we can count that in the code. So here you can see we will have 2 counting inversions, so this count will become 2 because 1 is smaller than these 2 elements. So if it is smaller than 2, so it is obvious that it will be smaller than elements after 2 also, so it will be simply that, like that. So now we sort this, so it will become 1 2 and 4. Now for this point we will calculate and see 5 and 3. So you can see 5 is greater than 3, which means there is a counting inversion, because I is element of I is greater than element of j, but index of I is less than j, so that means there is a counting inversion. So we will simply increment this, so it will become 3. So now it becomes 3. So now at this point they are sorted, so it will become 3 and 5. Now again if we check this array, so you can see now I will be here, so first it will pointing here and j will be pointing here. So now 1 is smaller than 3, so simply 1 will be added. Now 2 is smaller than 3, I has incremented because when we have added 1, now 2 will be also added, here it will be 2. Now you can see 4, so this has also incremented because we have added 1 and 2. So now 4 is greater than 3, so that means there is a counting inversion, and there is no element after 4, so that means we don't have to count any element. So we will see that in code how we can implement that. So now we will add here as we it will become 4, so you can see it has become 4. Now we've added the element, that is 1 2 3, and now I has been here, only, and j has been incremented to 5. So now if you check 4 is smaller than 5, so which is 4's index is also smaller than 5, and it is in first array. So that means we don't need to count any inversion, it will be directly added, so it will become 4 and 5. So now we have got our counting inversions as 4. As you can see, I have not written the answer, so output is exactly 4. So you can see the pairs that will be formed are, we will write the pairs here. So pairs will be, where is the mouse? So pairs are, I will write simply, so 2 and 1 and 4 and 1, these are two pairs, and then the pairs are 4 and 3, and the other pairs are 5 and 3. So you can see we got our 4 counting inversions. So these are our total count number of counts of inversions. So you can see we simply implemented the merge sort, and we implemented a simple logic that we at every step, if the first element is smaller than the first element of the other array, then we will simply increment our count. So how we can do that? So we will have to count all the values. If this value is smaller than this value, then it means it will be smaller than all the other values after this point. So we will simply count that number of inversions. So if our this point is for example, we will take let's take an example here. Like for example, we have 2 and 3 and 4. So you can see, and we have 1 here. So at this point you can see 1 is smaller than 2, so it means it is smaller than all the values after that, 3 and 4. So we will say, if we have a value here also, like 0 you can take for example. So now if our value is here, that is I is here and j is here, so how we will count our values? This is our mid, so it will be I minus j. I minus j will be the number of elements. So you can say mid minus I at the point we are leaving this will be our count of inversions, number of inversions, because 1, 2 and 1 form the pair, 3 and 1 form the pair, and 4 and 1 form the pair for swapping, or you can say counting inversion. So let's see the implementation in the C++. So I have written the code. So you can see here is implementation. So basically I have first of all starting from where I have created an array, similar example, that is 2, 4, 1 and 5 and 3, and I have calculated the size of array. Then we have created a temporary array that we will pass from here only. So in this approach it takes it takes O of n space. If we have to like make a different array, we cannot modify this array. If we can modify this array, so we can improve our space complexity also. But for this example we are taking a different array. So as we I have called this function, so this is a merge sort function, so we will call this. Now we have passed our array, temporary array, and left and right. So left will be 0 and right will be n minus 1. So if n is 5, so it will be 4. So we will then make our initialize our mid and count variable. So now we will check while left is less than right, right is greater than left, then only we will split the array. If this is not true, that means we have splitted the array into single elements. So then we will call our merge function. So in this we are finding the mid, then we are calling the merge sort function again recursively, passing the index that is left and mid. So and for the other we will pass mid plus 1, because we have passed the mid. So the next starting for the next array will be mid plus 1, and right will be the ending. So now as we have splitted all the, after we have splitted all the elements, all the arrays into single elements, then we will call our merge function. So it will be called here. So we will pass left, mid and right. So then in this function, as you see, we have called all the arguments here. So now we will initialize our count variable. So we will return this count variable, and it will get implemented or added into this count that we will return finally. So in this we have initialized our I to left, that is starting, and j to mid, that is starting of the other array. So these are basically this, I told you this pointers, that is I is this and j is this one. So now if we call them, so k will be left, because if many times we do a mistake, that is if we keep k as 0, k is not kept as 0, because k will change for every array, because we are adding the elements in same array. We are not creating different arrays, so k will not be 0, it will be starting of that array that is left. So now we will check while I is less than mid minus 1 and j is less than right. So we will check if the value is simply the first value is smaller than the second value, that is the array value of first array is smaller than the value of second array. Then we will simply just a second, we will simply add that array into temporary add the value into temporary array. And then if we will check if this is not the case, that means the counting inversion is forming. So then we will simply add the mid minus I. As I told you, mid minus I will simply count all the elements. If mid is here, that is mid is at 4 and I is here, so then it will simply subtract this element, and then it will add all the three count all the three elements. So this step is counting our inversions. So as I told you, so now we will check if we are ended this condition. That means there are maybe some elements left which are equal or something. So we will add the remaining elements to the temporary array. So I will be simply less than and -1, and k is the index that we are using for a temporary array, storing the values to that. Then simply we will add that, and we will traverse for the second array also and add all the remaining elements. Then we will simply copy the all elements to the original array and return the number of count, because now if we don't want, then we need not to do this step. So this is basically if we have to return the sorted array also, or you can say, then we will simply return the count. So count will get added, so it will be recursively be added here. Now then after we have got the count, we will return the count simply. So let's see and run the code. So actually, if you don't get this logic, that is how we are getting this made -I, so you can refer to Geeks for Geeks website. So they have a great explanation, or you can refer more videos. So you can see we have got the answer, which is true, correct. You can see 4 is our answer. So actually I've written where I've written the answer. So yeah, this was it. So it took n of log n time and O of n space. So as it is using merge sort. So this is how you can approach this question in interview. Thank you for watching, guys, and do like this video and subscribe to the channel for more such videos. And if you want me to make more videos, then you can comment down below for whatever videos you want. Thank you for watching, guys. Thank you.